But thankfully, we're not going to make you wait now. Smooth, right? Because we're going to hand over to our second speaker of the day, who's going to teach us why we should learn Terraform and hopefully make me a little less scared of it. Okay, welcome, Elizabeth, everyone.
Good morning. Thank you so much to Women Techmakers and the sponsors for having me. I'm Elizabeth Murphy. I'm a software engineer from PwC. I've been with PwC for over 4 years, coming in through a degree apprenticeship in 2020. Since then, I have won the Outstanding Apprentice Award at the Women in Tech Awards in 2024. I graduated from university and I've been building my tech toolbox, seeking to become a well-rounded engineer who can design, build and maintain her own applications. And my goal by the end of this session is to convince you why you should learn Terraform. When I thought of the cloud, I thought of lots of certifications and a very steep learning curve. I started learning about the cloud when I was asked to study for the GCP exam. And from watching all of the different videos, I was learning lots about Google Cloud Platform and their different services, but I still didn't understand what the cloud really was and how it was useful to me as a developer. I saw containerization as the go-to way for hosting my code, and anything more than that seemed out of scope and someone else's job. I didn't get the knowing about cloud infrastructure, and the cloud would help me as a developer. Little did I know that learning about the cloud and cloud infrastructure would actually make me a better developer, and that there was a way to build cloud resources using code. And that's where Terraform came in. Terraform is an infrastructure as a code tool that enables you to create, modify, and destroy cloud infrastructure. Terraform treats cloud resources as objects, with the resource configuration being configured using variables. So here we can see an example of an AWS S3 bucket being created using Terraform, with example as its resource name and with the name of the bucket being my Terraform test bucket. But you may be wondering, what if I already have resources in the cloud? How am I going to bring them into Terraform? So that's where the Terraform state file comes in, which you can import all of your existing cloud infrastructure into the state file. And then Terraform will compare your code configuration to the configuration it has in the state file. And will then tell you what it's going to create, update, and destroy. But as with any technology, we need to weigh up the pros and cons before we decide if it's the right technology for us. So some of the benefits of Terraform: improve security. By writing your cloud infrastructure using code, if your infrastructure ever goes down, it can easily be spun up again, making your infrastructure more secure. Reusability. Making your cloud infrastructure using code means that if you say want to create dev and prod instances which are replica of each other, you can reuse the code, and just for generally if you ever want to reuse the code again. And the Terraform registry. I see the Terraform registry as like a cheat sheet to learning Terraform. It contains templates and documentation for all different kinds of cloud resources, allowing you to start building in no time. And as with any technology, there are some drawbacks. So initial understanding. Even though the Terraform registry is very useful, you need to have a kind of idea of how Terraform works, but I'm hoping to address that today. And looping works slightly different in Terraform, as well as some dependency issues when creating resources using code. So to cover initial understanding, I'm going to start with a basic example, just so we can kind of see the structure and how we would create a resource using code. So today I'm going to create an AWS DynamoDB database called table. So when I want to create this resource, I go onto the Terraform registry and look up AWS DynamoDB table. Here we can see I have the resource type, which is AWS DynamoDB table. I have the resource name, which is basic DynamoDB table, and I have the name of the table itself, which is game scores. We can see there's lots of different variables, including attributes and the hash key, which is like our primary key. But I then want to know, what do I actually need to include? That's where the Terraform registry helps me out. So I have the required arguments, so I know what I need to include to build this resource in Terraform, as well as the optional arguments, which is things I might want to use to make it more tailored for my solution. And here's something I made earlier. So we can see the resource, AWS DynamoDB table. I have fruit as my resource name and fruit as the name of the table. My hash key is name, so that's going to be my primary key in the table, with the attribute also being defined. And the only optional thing I've added is the billing mode, which is pay per request. But then how do I actually run that code and move it to my cloud infrastructure? So these are the 3 core commands you need to know in Terraform. So Terraform init, this sets up your Terraform project, which at the minute will include my main.terraform file, which I've just shown, as well as my provider.terraform file, which will connect me from my Terraform configuration to my cloud provider, which is AWS. Then I have my Terraform plan. So this will compare my configuration in my main.terraform to my configuration in my state file. And it'll see what's changed, what do I need to create, update, and destroy. And then we have Terraform apply, which, as it suggests, will then take everything that's due to be updated and apply it to the cloud. So here we can see from what I made earlier, I've already set up my Terraform init and run that command. So my project's already set up, but I've just ran Terraform plan. We can see an AWS table with a resource name of fruit will be created. We have the name, which is fruit, and we can see all of the different attributes, and everything I added is already there. We can also see at the bottom, it says it's going to add one thing, change 0 and destroy 0. So that means that I know that nothing else is being created that's unexpected. So then for a bit more of a complex example, we're going to add in some looping and some variables, just so you know how this would work and to address our second drawback. So you'll see 2 files we have that we recognize, so our main.tf and our provider.tf, but we've added 2 new Terraform files, so our terraform.tf vars and our variables.tf. So in the variables.tf, that's where we declare the variable, which in this case, it's called grocery store and is going to be a list of strings. And then in our terraform.tf vars, we then have, that's where we're going to store the values for the grocery store variable. So that's vegetables, meat, and dairy. What I'm going to do is I'm going to create 3 separate DynamoDB tables, one called vegetables, one called meat, and one called dairy. So here's the code. You can see it looks very similar to our previous code with the same resource type, the same, we have a different resource name called grocery, and then we have the looping functionality. So I'm going to have a for each loop going through the grocery store variable. We can see the name I'm then pulling from that for each loop, each value in the array. So vegetables, dairy, etc. I'm then going to have the hash key being the same as in the previous resource, and the billing mode is kept the same. You'll also notice I've added some tags. This is because I want to be able to find this resource very easily in AWS, so I'm going to set the name tag to the same as the name of the table so I can find it easily. And here's another example of a loop. So this is using count instead of for each. I'm using this as an example because you can only use one of them when you're making a Terraform resource. So then that can be quite frustrating if I say want to add multiple loops inside a resource. And that's where dynamic blocks come in. I don't have time to cover that today, but I just thought it's something to be aware of and it's good to know. So then I ran up my Terraform plan again. The plan was too big for me to show on the screen today, but you can see my last table is being created with a name of dairy. The tags is also dairy and it has the pay per request billing mode and everything. And we can see at the bottom, the plan is 3 to add, adding the 3 different tables with 0 to change and 0 to destroy. Terraform makes cloud infrastructure manageable, scalable, and reusable. Whether you're a beginner or an experienced engineer, learning Terraform as a skill will future-proof your career. So why not start today? Thank you so much. You can add me on LinkedIn, and I hope I've convinced you to add Terraform to your tech toolbox. Thank you.
Thank you. Do we have any questions? No, I have one if that's okay.
Yeah.
The examples that you had were AWS, but you mentioned that you started with GCP. How much, if at all, did you find going between the two, or does Terraform make that a bit more neutral so that the provider doesn't matter as much?
So the Terraform registry is going to help you out completely in that. So it has all of the different documentation and templates for AWS, GCP and Azure. So whichever one of the three main cloud providers you're using, it'll help you out.
Awesome. Thank you very much. Thank you again.